Let's verify whether the given set, it's a unit set containing 0, is a group under the usual multiplication. In the previous video, we were able to satisfy the conditions for a group and say that this set is a group under the usual addition. This time, it's on the new operation, usual multiplication. To do that, we need to establish all the conditions and at the same time show that it's both non-empty and closed under the given operation. Of course, we already have an element for this set. We have 0. Then that's very clear that this is non-empty. As for the closure property, we know that for an element, here we have 0, and if we're going to multiply 0 to another element which is just itself, we will have a result of 0, and that is actually just element of G still. Therefore, we have established that there is a closure property for this given set. Let me place it here. 0 times 0 is 0 itself. Now that we have done these two things, let's proceed to the conditions for a group. We have G1, G2, and G3. G1 is for associativity, G2 is for the existence of identity element, and G3 is for the existence of inverse element. We're going to do it step by step because if G1 will not satisfy, we don't need to go to G2 and G3 and further say we can automatically say that it's no longer a group. But of course, if one is satisfied, we proceed to the other until we finish all. So we have G1. We need to show, of course, we're going to let star be the usual multiplication so that I could use star as we go through with our proof. So we are going to establish the star is associative in G. So we are going to let here 3 different elements, A, B, and C, element of G, though they are recorded or represented differently, but of course you only have one element. That would mean all of them are 0. Just for the purpose of establishing that A star B star C is the same as A star B star C. So under multiplication, we have here A times B, which is, of course, we could have here automatic. We could have 0 times 0, and the outside would be 0 as well. This would mean the other side is also 0 multiplied. Let's use, we can use here the stars so that we could have similar steps, 0 and 0. And this is 0. Star 0 is also another times 0, 0 times 0. You will have 0 on both sides. We have the same values for both sides of the equation. This would mean that associativity holds and that the operation star, which is the usual multiplication, is associative in G. That means we have satisfied the first condition. As for the second condition, G2, let me use other color here because we'll be using the spaces here at the bottom. Now for G2, this is for the existence of an inverse element. That would mean let a element of G. Again, we know what that element is because there's only one element. But let's just do it like this to practice. We need to find a certain E, which is also element of G, such that we can satisfy this. A star E is equal to E star A, which is equal to just A for all A element of G. But then again, we only have one element, but let's just do it anyway. So we have here A, E is A times E. The second form is E times A because, and since this is commutative, we can write here AE, AE. So we have the same values for both sides of the equation. What we just need to do is to finally pair it with this final form. So we have AE is equal to A. This is under multiplication, so we can divide both sides by A. We have here E is equal to 1. So obviously, E1 is not an element of our G. Now, before we talk about that and decide later whether this is a group or not, there are many conflicting issues here. Number one, there are some concerns like there is an identity here, and that identity is 0. Because if you have 0 times 0, it's 0 itself. Now, there are some concerns that accepts that. But there are also some concerns like, since we are still on usual multiplication, our identity is still 1. And in this case, 1 is not an element of G. Therefore, this will still fall into an idea that the group here, the set containing 0 under usual multiplication, is not a group. But to add another thing, let us try I tried here to represent it algebraically so that we could also practice this as we move further to other groups, and we could draw relationships, etc., etc. Take note that yes, this is equal to 1, but that is possible if you were able to cancel a over a. But take note that if a is equal to 0, because that's its only value, this is not possible. This is no longer equal to 1, because you will have an indeterminate form 0 over 0. From here alone, even without reaching this point here and deciding that since 1 is not an element of G, then G2 is not satisfied, or the idea that we will accept 0 as identity and move further to our inverse, just from here alone, algebraically, a over a, which is equal to 1, is not possible if the only element in our set is 0, because you will have an indeterminate form here. Obviously, all of these discussions will lead us to an understanding that G2 is not satisfied. With this already, we don't need to proceed to G3, which is inverse, which is of course in the first place the inverse of a number, especially in usual multiplication, is its reciprocal, and you will still have 0 over 0 just like this. Just this G2 itself, we can now say that, going back here, okay, we cannot say that star is not, it's not star. We say that G is, pardon, let's have it like this. G, which is set containing 0, is not a group under star, which is we defined earlier as the usual multiplication. Okay? For some who will accept this idea, you will still stop at G3. But G2 here, saying that there's no identity, it's already enough for us to say that it's not a group. Because again, aside from this saying that a over a is 1 and not element of G, in the first place, this expression will have indeterminate form if a is equal to 0. So again, with this, our set G is set containing 0 under usual multiplication is not a group. Thank you very much for watching.